Now, this is number 8 on page 390. This is number 8. So let's do this one. It says f of x equals 1 over 5 x minus 4 squared x plus 1 squared. Okay, we already know we're going to have 4 roots. It's going to cross the x-axis 4 times. Okay, so if we draw a graph, okay, and then we put our little table of values over here. So x and y. Now, where are the points where it's going to cross? Well, we have x is minus 4, so x minus 4 equals 0, x has to be 4. So we have 1, 2, 3, 4, we have a root at 4. Notice we have 2 of them. So this will be a turning point. We don't know whether it's an absolute min or an absolute max, but it's definitely a turning point. Okay? Now the second one, x plus 1 equals 0. So remember it has to be x equals negative 1. And that's over here. Alright, now we have our 2 roots. We need to pick points on either side and between. So let's do negative x equals negative 2. This is x equals negative 1. Let's do 0. It's an easy one to do. Let's do 2. We'll do 3. We've got 4. And then we'll do 5. Okay, so a little more than we had the last one because we've got 2 points right here. Alright. Now, we've got a quadratic. Okay, sorry, not quadratic, a 4th power. So we have, that's going to be an even power. That means that the end behavior is either going to be both positive infinity or both negative infinity. In this case, because we have no positive x, no negative up front here, it's going to be both positive infinity. So we know this thing's going to look like positive infinity on the end behavior. Let's take a look at it a little more closely, though, on these points here. Now, let's plug in first. Negative 2 minus 4 is negative 6. Negative 6 squared is 36. Now 36, now negative 2 plus 1 is negative 1. Negative 1 squared is 1, so 36. 36 over 5, that's going to be 7.2. Positive 7.2. Okay, you can check that on the calculator, or just be doing a hand like I would do. All right. Second thing, so we've got, that we'll put these graphs on in a minute. Now 0. 0 minus 4 is negative 4. Negative 4 squared is positive 16. Okay. 0 plus 1 is 1 squared again. 1 squared is 1. So there's 16 over 5. Well, 16 over 5 is 3.2. Now 2. 2 minus 4 is negative 2. Negative 2 squared is 4. 2 plus 1 is 3. So we have 4 times 9, which is 36. So 36 over 5. Again, we saw this. It's going to be 7.2. So 36 over 5 is 7.2, because 36 over 10 is 3.6. So 36 over 5 multiplied by 2, 7.2, tricks. Okay? Now, 3. 3 minus 4 is negative 1, negative 1 squared is 1. 4 squared is 16, 16 over 5 is again 3.2. Notice we've got a pattern here, okay? And no negatives, no negatives. Now, last one, 5. 5 minus 4 is 1, 1 squared is 1, 5 plus 1 is 6. 6 squared is 36. So 36 times 1 divided by 5. 36 over 5, again, you know, is 7.2. That's right. And hang with this. Okay? Now, let's take a look at this thing. We have up here, negative 2 is 7.2. So we have negative 2 and 1, 2, 3, 4, 5, 6, 7. Just guess on this. Perfect, because I'm going to go inside on here so just get a feel for it. Then we have 0 is 3.2. Alright. Then we have 2, which is 7.2. It's up here again. Okay, 3 is 3.2, that's down here. And 4, and then 5, we have 7.2. So 5, 7.2. Alright, so we've got this W shape here. Now, end behavior, we expect the boundaries to be positive infinity and positive infinity because this is a positive 4th power. So we'll draw this down. You're going to have to use your imagination on this. Should come out something like a W. Okay, it looks pretty close, not bad for guesstimating on the edge here. Now let's take a look at some analysis here. Absolute minimum is 0, absolute max is positive infinity. Okay? What are the turning points? Well, there's one here, and one here. These guys are where the graph turns. Okay? Now, these two, you'll notice, are local and absolute minimums. Okay? They're as low as the function gets. They're the local and absolute minimums. Okay? The graph doesn't get, function doesn't get any lower. Notice we'll never have positives in this function. Never. Okay? Because these square terms. Squaring a number makes it a positive. Alright? And you have a positive up here. Now, this is a local maximum. Okay? This turning point here. This turning point looks like it's at 2. So 7.2 is our local maximum. It's not the absolute max. The absolute max is plus infinity and plus infinity. This function will go to infinity if you keep giving it numbers. But a local maximum of it, remember, kind of a smaller peak in a mountain range. Okay, not Everest, but certainly not a hill, not a plain, but certainly a smaller mountain. Okay, little guy here is the local maximum. Now these happen to be the local mins. This is the local and the absolutes because it doesn't go lower. This is the local maximum. So when you're graphing, to sum these things up, when you're graphing these functions, make sure that you first put down the roots. Okay? Notice if you have a squared term, you know that that root's also going to be a turning point. Okay, so expect to see some turn on that graph. You can expect that. Now, when you're putting them in, don't forget if it's in parentheses, you have to take the opposite value. So if it's x minus 1, it has to be x equals plus 1. If it's x plus 5, it has to be x equals negative 5. So take the opposite, plug those in. Then pick a few values. You might have to pick 5, okay, maybe 4, you might get away with 4. Pick some values on either side and in between those roots. Find out what the graph looks like. You can draw again from the left to the right, straight, nice curve as best you can. You should get a feel for what this thing looks like. Then identify the local minimums and the local maximums by looking at the turning points. Okay, that's the turning points of the graph. Now, this is on page, so the problems for this one are on page 390, and their numbers 4 through 8, although this is 8, so you don't need to do that anymore. If you want to redo it again, you can. Okay, 4 through 8, 13, and 15 through 20. Okay, this is on Homework Central. It's page 390, 4 through 8, don't do 8, 13, 15 through 20 all. Okay, so take a look, try, it has to be on graph paper because you're graphing, graph paper. See if you can spot local mins, local maxes, make sure you graph these things and make sure they make sense with end behavior.